In this module, we'll focus on data visualization, and in particular, how you can use the very powerful ggplot2 package from the tidyverse to create an incredibly diverse array of plot types and graphics. Now, we'll come back to this actual plot that I'm showing here. This is Napoleon's March on Russia. It's a classic example of data visualization, and it's one that's often raised as an example of how ggplot2 can recreate even very complex, visually rich graphics. Now, in the last module, we spent a lot of time talking about the dplyr package from the tidyverse, and in particular the dplyr verbs like filter, mutate, select, and arrange, and how these functions give you a tremendous amount of control over even very, very large spreadsheet-like data sets. And one of the advantages of dplyr is that it makes it very easy for you to summarize even very large data sets and add summary statistics to those data. But I want to caution you that if you're only using dplyr and you're only working with data in a spreadsheet form and visualizing it in these tables or tibbles in the tidyverse, even with summary statistics, that view can be very misleading. A classic example of how summary stats can be misleading comes from Francis Anscombe, a statistician who in the 1970s coined something that we now call Anscombe's quartet. If you're not familiar with this, it refers to 4 data sets that by a range of different statistical properties, different means, variance, correlation, linear regression, R-squared that I'm showing here, those 4 data sets are identical or nearly identical. And yet, when you plot those data, it's clear that they are fundamentally different data sets with different structure. And so the point here is that relying on spreadsheet or even statistical summaries of spreadsheets alone can be very misleading, and that plotting data can tell you a lot about the nature of that data. And so in this module, we're going to spend a lot of time talking about data visualization in R and how we actually go from spreadsheets or data frames, if you will, to something visual. How do we use a language to make that transition from data to visualization? Before we jump into R and we start using ggplot2, I just want to impress upon you that compelling graphics can really dramatically increase the impact of the data that you're trying to communicate to your reader or your viewer. And there are several classic examples of that. I picked out a few here that we'll go over. They're ones that are often raised in tutorials and videos and talks about ggplot2 or about data visualization, so these aren't necessarily unique, but I think they're really impactful. The first one that I'm showing here is from Ed Hawkins, who was affiliated with NASA as a data scientist and wanted to visualize climate change over time. And so I'm just going to hit play on this. And what we can see is each ring around this marks a season, and the rings move out as the temperature warms 1 degree, 2 degree globally. And the lines are colored to indicate the temperature. That creates a spiral, if you will, that we can also tilt up and see as a line plot stacked here vertically in front of us. So this is an animation, not a static graph, but it's still one that was very visually compelling. You don't need to know a lot about climate change to understand that that's something that really has a striking potential impact. Now, we don't need fancy animation to make a compelling visual. And as an example of that, we can look to John Snow and his maps from the cholera outbreak in London in the 1850s. Again, a classic example of data visualization, but if you zoom in to the map, you can see that Snow made a little horizontal dash at any address where there was a cholera outbreak, and of course there's the famous pump that we now know is the source of that outbreak. And just by plotting the data in this way, you could appreciate that there was a preponderance of cases sort of piled up in houses near this pump. And so this is the famous example of Snow taking the handle off the pump to prevent people from continuing to get sick at this source. Another example of data viz success is that of Gapminder. And if you're not familiar with Gapminder, it's an online resource that hosts and aggregates large amounts of socioeconomic data, agricultural data, public health data for countries from around the world, and then provides a toolkit of plotting tools and animation tools that let users really make sense of these very large and complicated data sets pretty easily. And so this is a classic Gapminder plot. We have life expectancy on the y-axis and income on the x-axis. We have a points plot here where each point represents a single country. So this is Italy. Each country is colored by its region in the world, and then it's sized according to its population. So India and China are the largest. And we can hit play here and over time watch as the life expectancy and income of these countries change. And after a bit of sort of bouncing around here, what you see is this trend upwards and to the right as by and large the world population becomes longer living and wealthier. And so overall, a very positive message from a very simple visualization. And in addition to that message, if you scroll back and you sort of slide through this timeline with higher resolution, looking a little more closely, what we can see is global events, single events that had a massive impact on the population of one or more countries. So for example, if we scroll forward to 1918, we can see the population of nearly every country drop. And that, of course, is likely the Spanish flu pandemic that swept across the globe. If we go forward to 1940s, we can see several countries here, Germany, Japan, all finishing up World War II and their populations suffering from involvement in World War II. We can move forward, 1960, we can see China over here on the left dip down suddenly. That's from the Chinese famine in 1960. And as we move forward, we can see both China and India move from sort of the back of the pack here with respect to income all the way up close to the front, indicating those very large populations now becoming much, much wealthier. Now that you've seen some examples of compelling data visualization, let's turn our attention back to R and to thinking about plotting in R. At the end of this module, we'll come back to at least a couple of these, and we'll show that you can actually reproduce these complex animations and visuals even directly within R using ggplot2. Since the main way we will generate plots in R will be through the ggplot2 package, it makes sense to talk just a little bit about the sort of conceptual underpinning of ggplot2. And we can do that by starting with the first two letters, GG. This stands for the Grammar for Graphics, and is a concept that predates ggplot2. It was actually articulated in this really important data visualization text by Leland Wilkinson called The Grammar of Graphics, where Leland relates the notion of a grammar that we typically think of it in spoken and written language to how we need to think about articulating and expressing a graphic. And so he points out that grammar gives language rules, and we also need rules when we're making plots from data. He points out that grammar has actual technical meaning in linguistics, and that's important when we think about how we would want a grammar to apply to making a plot. We want anything we say to have technical meaning. And then finally, and importantly, grammar makes language expressive. So he says a language consisting of words and no grammar expresses only as many ideas as there are words. By specifying how words are combined in statements, a grammar expands a language scope. And so hopefully you get the idea here. There's a lot potential benefit from applying a grammar to graphics. We can expand the scope of what the data alone can do. This notion of a grammar of graphics was expanded on by none other than Hadley Wickham in his 2010 seminal paper called A Layered Grammar of Graphics. It's this article that introduced the world to ggplot. And in this article, Hadley proposed an alternative parameterization of the grammar based around the idea of building up a graphic from multiple layers of data. Let's take this notion of a layered grammar of graphics and actually apply it to some data. And so I think the key thing that we need to think about is what do we need to produce a plot? To arrive at a grammar for graphics, we need to understand the generic ingredients that we can use to make any plot. And so the first ingredient, of course, is data. And in our case, we'll start with the so-called MPG data set from the tidyverse. This is miles per gallon. It's data for different manufacturers and models of cars and their mileage both in the city and on the highway. So if we have this data, then we can begin at least the first part of our ggplot exercise. Now, we need additional ingredients here, and one of those is the aesthetic mappings. In ggplot2 lingo, this is called aesthetics or AES. It's the AES command. And the AES command lets you take certain variables like mileage in the city and map it to the x-axis, and the number of cylinders in the engine of the car and map it to the y-axis, and any other variable and map it to other attributes of the plot. For example, the year of the car could be mapped to the color or size or shape of something you're showing on that plot. Now that you've mapped different aspects of your data to the aesthetics of the plot, it's time to actually tell ggplot2 what kind of plot type you want. In ggplot2 language, that's called a geom or geometric shape. In other words, do you want a points plot or a bar plot or a histogram? So for example, we could specify that we want a geometric points plot. And now that we have our aesthetic mappings and our geom, we have our first ggplot. You can also set your coordinate system using the coord function in ggplot2, but by default, it's set to Cartesian, so sort of standard XY plotting space. But you can imagine situations in which you might want to change that. For example, if you want to make a pie chart, that's not XY space, that's going to be a polar coordinate system. Those are really the main ingredients that go into making a plot in ggplot2. There are many other aspects of this grammar for graphics, as I'm sure you could imagine, that you may find useful, but that aren't essential or required to make a plot. I'll show you a couple of those now. For example, positional adjustment in ggplot2, that's dictated using the position command. It can take a plot like this, where we have box plots with overlaying points, where all the points, because they are aligned with the same x variable, but have different y values, they're sort of lined up here and stacked on top of each other. Using a simple jitter position adjustment, we can adjust very slightly the x position while keeping the y value the same. This allows us to see and better appreciate the large number of points here and gives a much more natural look to the plot. Another really useful thing to know how to do in ggplot2 is using the facet function. And faceting lets you take a plot you were already making, in this case, cylinders on the y-axis and city mileage on the x-axis, and reproducing that plot for each element in another variable in your data set. In this case, let's say manufacturer. So I would produce a cylinder versus city plot for Audi, a cylinder versus city plot for Toyota, one for Ford, one for Chrysler, for however many manufacturers were listed in this column. And so what that produces is many plots that are nearly identical except for one variable, which is, in this case, the manufacturer. And it gives you an easy way to quickly visualize how one variable impacts the data that you're looking at. So there are many examples of faceting, or it's also called small multiples. This is an example dating back to the 1800s in a census taken by a US state looking at the number of deaths for each state. And so the faceting variable here is state, Alabama, Arkansas, California. You have age on the y-axis, and you have numbers of deaths on the x-axis, with males coming out to the left and females coming out to the right. And so this kind of visualization lets you pick out trends in states, for example, Montana, Idaho, Dakota, lots of deaths in men of young age, 20-ish. I'm guessing that's because of all the sort of outdoor activities, hunting, dangerous mining, things like that that happened in these states in the 1870s. You can also facet by other variables, in this case state, but why not disease? And you can see, in this case, the huge impact that measles had on very, very young children, whether it was boys or girls. No discussion of ggplot2 would be complete without at least some discussion of ggplot's themes. These are determined using the theme command, and here you can see theme black and white, or theme underscore BW gives you a graph that looks like this, but simply changing the theme to theme underscore classic changes it in subtle but important ways, removes all the grid lines from the inside, removes the box around the outside, and gives you this cleaner looking graph. And these themes are wonderful because actually, when you start to think about the details of these plots, whether you want horizontal or vertical grid marks inside, whether you want borders, what size font you want, the positioning of the font, you can imagine that a lot of different parameters need to be specified to tune the graph just the way you want. And so what themes do in ggplot is they package all of these parameters into a single function, in this case, theme gray or theme black and white or theme dark. And if you're interested, you're not restricted at all to ggplot's complete themes. There's a lot of ggplot theme packages out there that let you add aesthetics and a look and feel to your plot that emulate popular data visualization platforms. For example, the bbplot package will let you make plots that look like the BBC, and you can make your plots look like they come from The Economist or 538 or the Wall Street Journal, or for some unknown reason, if you want to make your plots look like they come from Excel, there's a function for that too. I want to come back to this idea of Hadley Wickham's layered grammar of graphics, because we haven't really talked about what he means by layering data. And it's really critical to understanding how we'll use ggplot2 in R. And so to illustrate that, we're going to start with some code here that I'll walk through, and I'll reference the different ingredients that we've already discussed and the outputs that we get from that code, and kind of mixing those ingredients together. I think once you understand these ingredients, you really will be able to construct your own graphs using this same sort of grammar. So we're going to start with ggplot2 and the iris data set. And we're going to forget about all this for now. I'll uncomment it and we'll talk about these lines as we go through. But right now, if I just have data, a coordinate, remember we don't have to specify Cartesian coordinates, they're there by default, and then a theme. Okay, so data and some themes here. What I get is just a blank canvas, right? Just a square with nothing in it. So data alone does not make a plot in ggplot2. I haven't specified any aesthetics. So let's do that. Let's turn on the aesthetics here and map species from the iris data set to the x-axis and sepal length to the y-axis. So now I have data, a coordinate plane here, a theme, and aesthetics. And I now don't have a totally blank plot. I have at least variables mapped to the x and y axis. All right, still no actual plot though, because I need to specify a geom. Remember, that's another one of our critical ingredients. In this case, let's do a geom box plot, and we'll specify a few things here like the color. And so now we actually get our first plot. So this is the first sort of indication of our layering here. We're passing this data, if you will, through layers of commands. First, aesthetics to map variables to the x and y axis, then geoms to actually get shapes, and then a theme to give an overall look and feel of the plot. And because these are layers, I can continue to add more and more of them if I'd like. I'm not restricted to a single geom or shape on my plot. I could turn on a points geom, for example, and add points to my plot. So now I have two geoms that are going into making this graph. And as we talked about, there's additional things I can do, like adjust the position using the position argument here, position jitter, and move those points from being stacked on top of each other to jittered. Okay, so now what we're going to do is essentially reproduce that, but for a different data set. So we're all going to open the R script now, and we're going to start working with ggplot2 in RStudio. Okay, to get started, we'll begin by loading some R packages, and of course, we start off with the good old tidyverse. Why? Because we need ggplot2, and ggplot2 is part of the tidyverse. So we begin by loading the tidyverse. We're also going to load into our R environment our color brewer, which is a useful package for accessing and dealing with colors and palettes. And then we'll also load Plotly, which is a great package for turning static ggplot plots into interactive plots. So if you don't have Plotly or R color brewer, then you'll have to follow the instructions I gave previously for how to download and install and load R packages. Once you've done that, run a function that we ran from the previous module called data. And data lets us actually look at the data sets we have available to us in our current working environment. And if you scroll down this long list of data sets at the end, you'll see that there's some new ones that you may not have noticed here before that only appear if we have the tidyverse loaded. Packages or data sets that come along with dplyr, with forcats, with ggplot2, etc. And so one of those is the MPG data set that I referenced just a little bit ago. If we just run the MPG data set, we can see exactly what I showed you earlier: manufacturer, city mileage, highway mileage, cylinders, etc. Okay, so we have that data set in our working environment. We're now ready to actually start using ggplot2 and exploring this notion of a layered grammar of graphics to plot data from the MPG dataset. If we take this ggplot2 command and we just run it with no data, no parameters specified at all, we get, as I talked about just a bit ago, a blank canvas. If we pass it some data, in this case the MPG data set, we still don't get a plot because remember, we haven't really given all of those ingredients that we just discussed. So let's do that. Let's go ahead and provide some, not only some data, but some aesthetics where we'll map highway mileage and city mileage to the X and Y axis respectively. We do that, still no plot, no at least data displayed, but now we have our aesthetics mapped. Here's the city mileage on the y-axis and the highway mileage on the x-axis. And now we can provide this final ingredient, which is the geometric point, the geom, that will tell ggplot that we would like a points plot here. We'll run that and we get our first ggplot. So here we have city mileage by highway mileage, and you can see this nice linear correlation. The more efficient you are on the highway, generally speaking, the more efficient you are in the city. Okay, this is a very basic plot, and it's got all those basic aspects of our plots that you may have noticed before in publications or in talks, this sort of grayed background and vertical and horizontal grids. So we can start to manipulate or change the aesthetic of this plot and provide some more detail. So the first thing that we can do is actually provide another aesthetic argument here to the geom point command, telling ggplot that we'd like to map the number of engine cylinders to the size of the points. So this aesthetic is different than the main one we've specified because we're specifying this aesthetic specifically as it relates to the geom point. All right, so let's run that. And now we can see that the cars with the largest engine in terms of number of cylinders do the worst in terms of mileage, right? So these large points have large numbers of engine cylinders, big engines, less efficient, probably no surprise. Now, I mentioned just a minute ago that this looked like a nice linear relationship. We could do more than just eyeball that. We can add another geom, again, highlighting the ability of ggplot2 to layer different aspects of the data. So providing a geom point command followed by a geom smooth and telling it that we'd like a linear model fit here as the method. If we run that, we get a nice fit. Let's give it a minute. There it is. With confidence intervals, and so we've successfully layered on that additional aspect of the data. Now, with this plot, we can now add some axes labels and some plot titles and subtitles, and we can do that using the labs for labels command, specifying what we'd like to write on the x-axis, what we'd like to write on the y, if we'd like a title, and if we'd like a subtitle. So let's go ahead and run this, and now we have a plot that looks a little bit better, more human readable axes labels for the y and the x, and we have a nice title and subtitle here on top of the plot. Okay, but so far everything we've produced is the default theme for ggplot2, and I'm not a big fan of this gray background or the vertical and horizontal grids. So I'm going to take the exact code that I had before, but I'm going to add using this plus symbol. So in ggplot, anytime we're adding an additional layer, we add a plus sign at the end of one line to continue to the next. So I'm going to add a plus sign here, and I'm going to tell ggplot that I'd like to use their sort of standard theme black and white. I think that's a nice clean theme that makes the plot look better. So I'll go ahead and run that. And now I get this, right? So now I still have some grid marks, but they're not as numerous. I have a white background and I have a box around the actual plot space itself. If I wanted, I could change that to classic, which is a little bit cleaner even, no grid marks and no box. Once you're happy with any ggplot you've made, you can use the ggsave function. Give it the name of the file that you'd like the image to be saved as, and specify its width and height in inches. And ggsave just applies this save function to the most recent plot that you've produced. So go ahead and run that, and now I can expect to see a plot.png saved in my working directory. Okay. I can also do that manually here in RStudio. I can just say export, save as image, and I can choose the kind of image I'd like to export my plot as. So very easy to get stuff out of ggplot, out of R. Okay. We talked about how useful it can be to facet data when we're plotting, so I'd like to demonstrate that now. We're going to use the same code that we've been using for making a plot from this MPG data set, but we're just going to add, using the plus sign here after our theme, one more line, which is a facet wrap function. And the only thing that we need to tell facet wrap is exactly which variable in our data set we would like to facet on. We do that using a little tilde character followed by the name of the variable in our data set. So if we remember, the MPG dataset has lots of different things we could facet on, so feel free to experiment here, but I'm going to choose year. There are just 2 years of data in this MPG dataset, 1999 and 2008. So my facet's just going to have 2 plots. So we can go ahead and put my cursor on the code and hit run. And now we get this nice plot. So exactly the same style, aesthetics, and mappings that I had in my previous one, but now I have 2 plots, one for 99, one for 2008. And you can already appreciate the value of faceting here. For example, I can see that, sort of sadly, there are 2 models of vehicles in 1999 that were more efficient both on the highway and in the city than anything made a decade later. Okay, so once you're happy with any ggplot object that you've created here, any plot you've created, you can store it as an object in your R environment. Same way you would store anything in the R programming language. You use the assignment operator and give that object a name. So running the exact same bit of code, we now have an object called myplot that is a ggplot2 object. One nice thing about storing ggplots as objects in your R environment is you can call on them later in your code for various things. For example, I mentioned at the top of this script that we were going to use the plotly package, which lets us turn ggplots into interactive plots. So let's do that now. The main function from the plotly package is a function called ggplotly. And we're just going to tell ggplotly to do its thing for this plot that I just made, the one that we're looking at here. So we hit run. And when we do that, we get a plot that looks a little bit different in terms of the aesthetics. But what's really nice is that now I have these interactive mouse over tooltips. I can see the highway, city, and the number of cycles in the engine. And you can control and customize these tooltips in lots of ways. But there's lots of interactivity here. I can zoom in on both plots. I can reset the axes and go home to my original plots. Lots of interactive capabilities without really having to do any coding, just passing my plot to the plotly package into this ggplotly function. The plots that we produce don't have any color at all, and there's going to be lots of times when you're working in R that you're going to want to access individual colors or whole palettes of colors. So I want to take just a minute to talk about colors in R. We won't spend long on it, and there's lots that could be said, but this will at least give you a sense of what you can do. If you recall, at the top of this script, we loaded a package called R Color Brewer. R Color Brewer is a great resource for just getting started with colors. One of the key functions that we'll start off with is display brewer all. That will give us just a quick look at all the colors that we can access from this package. Here they are. These are the palettes. They fall into generally speaking, three categories. We have qualitative, or you could think of these as categorical color palettes here. We have diverging color palettes at the bottom, ones that start at one color and go to an opposite color. And then we have sequential palettes, ones that start at a low intensity of low shade of color and go to the brighter version of that color. So from yellow to orange to red. I can also pick just those palettes that are colorblind friendly just by saying colorblind friendly equals true. When I do that, I have a smaller set of palettes here that should play nicely with different forms of color blindness. And then finally, using the brewer.pal function, I can pick any number of colors from any of the palettes here. And I'm just calling the name of the palette here directly in quotes and the number of colors that I would like from that palette. So when I do that, notice that what is created is a single character vector of these codes. And these are important, distinct things in the color landscape called hex codes, 6-digit codes that uniquely describe a specific color. So if you take any of these codes, say this one, well, let's just grab all of them, and you were to type them into the R coding area here, let's say, just call this colors, use an assignment operator, and put them in here, you can see that immediately R recognizes these all as being colors and actually overlays the color on top of the hex code. So hex codes are a great way to always make sure that you're getting exactly the color you want without having to worry about a name. R will actually also recognize names of colors, so you could say red or blue or green or yellow, and it will overlay the appropriate color over top of that word as well. If you're interested in learning more about colors in R and where they come from, you might want to check out Color Brewer. It's the resource that the R Color Brewer package is really based on, and it was really developed to provide a tool for cartography, so map making. If we head over to the Color Brewer website, you can see that it really was meant to allow map makers to display a number of different things on the same space, on the same map, in a way that the human eye could still distinguish borders, zones, regions, information about that map. So you can see, you can pick different color schemes here and see what they look like. Sometimes looking at this website can help you actually pick colors you might want for a figure. You can toggle between sequential colors to diverging to qualitative colors. And you can see the respective hex codes that you've got for all of these. Okay? So to summarize, there are a number of advantages of this layered approach to the grammar of graphics. The first is that you can iteratively update a plot, changing specific elements as you need, right? It's very easy to add in new lines to this layer, changing any aspect of the plot. You have control even over high-level aspects of the plot, even the data itself. So, I could take the same ggplot2 code, swap out different data sets, producing the same plot with the same aesthetics, but with different underlying data. This layered approach allows you to stack different plots on top of each other. For example, you could make a box plot and put the individual data points on top, or as we did in the script, you could make a points plot and overlay a fitted line. Layers also make it easy for you to use comments to toggle any layers on or off. So I could just prepend any line with the number sign, toggle it off, regenerate the plot, and at any point toggle this back on to bring that element or that layer back into my plot. Default arguments for each layer really minimize the need for you to dictate extensive amounts of details for the plot to actually appear. You'll notice that for my ggplot code, the lines didn't extend too far to the right. There weren't 8 to 10 parameters that I was specifying. There were 1 or 2, sometimes none, right? For themes, I just say the theme, open and close parentheses. So very, very few additional details need to be provided. Lots of default arguments that are already set. And then finally, and maybe less relevant to you, but still important for software developers, this layered approach makes it very easy for them to develop new functionality that plugs right into ggplot2. for example, some new statistical transformation can just become another layer or line that is itself a function or a package. And there's lots of examples of that. We won't go over them. It's beyond the scope of this module, but the ggplot2 package has proved to be very extensible, easily extended by developers. And there are a number of packages, many of which, if you work for any length of time in R, you're going to absolutely end up using. Things like ggAnimate to animate plots, patchwork to arrange plots together in a figure, ggRepel to help you get a convenient and aesthetically pleasing layout of text labels for many points, and on and on. So to wrap up this part of the module, I thought we could have a little fun and try to recreate some of the seminal data visualizations that I've highlighted throughout this part of the module. If you recall, my opening slide had this graphic on it. I said we would come back to this, and now we will. This is Menard's famous depiction of Napoleon's march on Russia. And it's a graphic that was intended to depict the heavy losses that Napoleon's army took as it moved from France to Moscow. So the thickness of this line indicates the size of Napoleon's army. And already, as I start to talk about this graphic, we're using a grammar that you could imagine being depicted in ggplot2. We have aesthetics, size or number of military mapped to line thickness. As Napoleon's army reached Moscow and began to retreat and return home, we now have a directionality. So advancing is beige and retreating is black. So we've mapped another variable to this, in this case, line color. So we have line size and line color mapped. We have a longitude and latitude on the X and Y axis. And then we have a second plot down here that shows the temperature. And so what happened to Napoleon's army is they took heavy losses, starting at around 500,000 troops. As they moved towards Moscow, the Russian army began retreating and moving back, burning and removing all resources in the path of Napoleon's army. And so they had nothing to sustain themselves. And by the time they got to Moscow, they had lost nearly 3/4 of their troop size. When they began to retreat, the temperature started to drop in winter, and that resulted in even heavier losses, such that by the time Napoleon's army returned to France, it had just a few thousand troops left. And so this graphic that maybe at the start of this module you'd thought would never be able to be reduced to a grammar actually is very easy to reduce to a grammar. And so we'll play around with making this plot or something approximating this plot in R. Andrew Heiss has actually already done that, and so I'm providing a link to his website here in this QR code. We're just going to use his code exactly, so acknowledgments to Andrew for going through the work of converting this into ggplot2 code. At the bottom of your script, you'll see 3 different code chunks, each recreating one of the sort of seminal data visualizations that I talked about earlier. Starting with Menard's Napoleon's March, the Gapminder data visualization, and then Ed Hawkins' climate spiral video. And just to say at the outset here, you do not need to actually run this code if you don't want to. In some cases, it involves more sophisticated or intermediate kind of ggplot2 coding. I'm putting it here just because I think it's really fascinating and exciting that you can make these kinds of sophisticated graphics with the ggplot2 package. So let's start with Napoleon's March. We can unfold that code chunk. You'll see some packages here you may not have. At this point, you should just go get those and install them if you'd like. I've provided the data on as text files to download from the module website, so we can, as long as that data is in your working directory, you should just be able to run these and load that data. And then we run some ggplot2 functions and store the data. Remember, we're making not just one plot here, but multiple plots. This is a sort of a complex graphic, and then we combine the plots. Once we do that, we've got a graphic that roughly approximates what I showed you from Menard's original publication. So we see Napoleon's advance and his retreat. So we successfully mapped direction to color. We mapped troop size to line thickness, and we even got our temperature map here on the bottom. Now, I didn't get the labels on here. I would have to play around with this a bit more to get it to work, but pretty close for what amounted to be only a couple lines of code here. Even easier is the Gapminder visualization. So it turns out there's a Gapminder package in R. So all we need is ggplot2, the Gapminder package, and then this ggAnimate, which is one of these add-on packages that works with ggplot2. And how it does that will become apparent in a minute. Once you have these three packages installed and loaded, you really don't have that much, just one single ggplot2 code chunk here where we pass some Gapminder data, we choose our aesthetics, in this case the X and Y axes, and map those map variables to those. Choose the size of the point to be the population size, the color to reflect the continent, and we're going to animate this, so we want the frame of the animation to be the year. We want this to be a points plot, so geom point. We choose our theme, and then these two lines at the end are not typical ggplot2 code. These are only possible because of the ggAnimate package. So what we are able to do with ggAnimate is choose a transition time, in this case year, and choose how easily or smoothly we transition through these years. In this case, I want it to be a linear transition. If we run that code, we see at the bottom of the screen that it's rendering an actual video here that it will display not in the plots viewer, but in the viewer pane, which lets us look at interactive or dynamic visualizations. So just a few more seconds for that to finish, and then hopefully we get that displayed right here in RStudio. Okay, so there it is. Lots of things you could imagine changing, including sort of formatting and aesthetics and the actual key here, but you get the idea. It's looping through this GIF where we can have the same sort of data and view of these interesting data that we had on their website. For this last one, Ed Hawkins' climate spiral, I'm not going to run this here because it takes a little bit of time to make this video, but not a lot happening here. I've got the tidyverse and ggAnimate. Again, I provided the input data if you want to go ahead and run this yourself, but we're just going to read that data into an object in R. We're going to work with that data a bit to sort of wrangle with it, binding the rows, so putting data together. You recognize some of these dplyr verbs, mutate, arrange, filter. So really doing some data wrangling there, and then finally plotting. And what you'll end up with is a video that looks like, see what I saved it as here at the end, climate spiral. You will end up with this, made in ggplot2. Should look familiar because it looks an awful lot like the original video. So really powerful stuff. Good luck learning ggplot2 and have fun.